Alright, so we've gone over the 0th and the first law. So in this video we're going to go over the second law of thermodynamics. And in many ways, the second law is my favorite law of thermodynamics, but it can be a little complicated to explain. So what I'm actually going to do is break this video up into two parts. In part one, I'm going to go over the simple direction of heat transfer definition of the second law. And in the second part, I'm going to go over the true entropy definition of the second law. But entropy can be a very complicated concept to explain, so I want to dedicate an entire video to that. But in this one, we're just going to go over the simple version. And the simple version says that during a natural, I'm going to underline the word natural, and I'll explain why later on. During a natural process, heat always flows from a high temperature medium to a low temperature medium. And I think this is something we're all pretty familiar with, right? We've all dealt with hot things and cold things in our everyday lives. And let's say, for example, you were to grab a cold can of soda. Then you would expect your hand to get colder because the can is cold. And you would expect the can to get warmer because your hand is warm. And that seems to be the natural order of things, right? Things go from hot to cold. You would never expect your hand to get hotter, and you would never expect the can to get colder. That just doesn't even make any sense. And that's exactly what the second law is saying. It's saying that heat has a natural direction in which it likes to flow, and that direction is always from hot to cold. Alright, so let me go ahead and clear this so we can get a more conceptual understanding of what's going on here. Alright, so let's say we have some metal pipe, and let's say this metal pipe has been outside in the middle of winter, so it's very cold. Alright, so there's my metal pipe. And then you come along and you decide to grab this pipe. Okay. So remember, the pipe was sitting outside and it was freezing, so let's say it's about 32 degrees Fahrenheit. And you should be around body temperature, so let's say you're at 98 degrees. Okay. And it's important to understand that we're talking about universal laws here, right? So what's going to happen is that when your hand grabs the pipe, the universe wants things to be at equilibrium, which these two are not. So it's going to start transferring heat from your hand over to the pipe. So since heat is leaving your hand, your temperature will go down. So 97 degrees, 96, 95, and that heat's being transferred over to the pipe. So this will go up to 33, 34, and this process will continue until you both arrive at some temperature. Let's say it's 65 degrees or something like that. So the universe will keep checking to see if these two are at equilibrium. And if they're not, this heat transfer process will take place. Heat will leave the hot temperature medium and it will go towards the low temperature medium until both of these are at thermal equilibrium. And here we can see why the second law of thermodynamics has to be the way it is, right? It doesn't make any sense that heat would go from the low temperature medium to the high temperature medium because the universe wants things to be in equilibrium. If heat is leaving the cold one, going towards the hot one, this temperature would go down and this temperature would go up, making them even further away from equilibrium, which the universe doesn't like. So the law has to be from hot to cold. Oh, and this is actually a pretty good example to explain something to do with heat transfer. Okay, so when you say things like this is hot or this is cold, there's actually no such thing as hot or cold. Everything is relative. So in the example where you grab the cold metal pipe, your hand was the hot object and the metal pipe was the cold object. So due to the second law of thermodynamics, heat is going to go away from your body towards the pipe. And it is that energy transfer, that energy leaving your body that you actually experience as cold. Okay? And let's go with the opposite example. Let's say it's a hot summer day and the pipe is really hot. And now, see, again, your hand didn't change temperature. Your hand was always at 98 degrees. But now, relative to the pipe, your hand is now the cold object. And now, due to the second law of thermodynamics, heat is going to transfer away from the pipe towards your hand. So again, there's no such thing as hot or cold. Everything is relative. It depends on whether energy is entering your body or energy is leaving your body. Okay, now I just want to talk about one last thing, because this is something that definitely confused me when I was taking my thermodynamics class. Okay, so when I was reading about refrigerators in my thermodynamics class, my initial reaction was, this thing can't exist, because this thing breaks the second law of thermodynamics. And the reason I thought that is because how a refrigerator works is that the refrigerator will have some refrigerated space inside, and that space will obviously be colder than the environment outside. The environment outside will be at room temperature, and the refrigerated space will be a lot colder than that. And the second law of thermodynamics says that heat always flows from the hot temperature medium, which is the environment, to the cold temperature medium, which would be the freezer. But the refrigerators do the exact opposite. How a refrigerator works is that it will extract heat from your refrigerated space and dump it into the hot environment outside. And that blew my mind. And that's why if you ever feel the back of your refrigerator, you'll feel a lot of heat. That heat is the heat that is being extracted from your freezer. That's how it works. So I was like, this can't be. Like, you just told me 10 pages ago that the second law of thermodynamics says that heat always flows from the high temperature medium to the low temperature medium, and then you tell me about this thing that does the exact opposite. And that's why I stressed the word natural at the beginning of my definition. Because it's important to understand that this is not a natural process. This is something that we did. This would never occur in nature. And that's the important part. That if no one is doing any work to the system, if the system's just happening naturally, it will always follow the second law of thermodynamics. And that's the important part to remember. So just in case you're wondering, yes, this does do the opposite of what the second law of thermodynamics says, but it does not break that law. And neither do things like heat engines and stuff like that. But yeah, that's all I wanted to cover in this video, and I'll see you in part 2.